Hello, welcome to Indie Dev Tools. Today, we are looking at vectors. So what are vectors? A mathematician may tell you that a vector is a number with a direction, represented with an arrow. With vector calculus, you can... No, we won't be doing calculus. Most of what we're doing is pretty simple, and the rest you don't really need to understand to use. So what do we mean by a number with a direction? Imagine you have to drive 2 kilometers to the northeast, or move a character on screen 10 pixels to the left. These are both vectors because they have a direction associated with a number. So how do we use vectors? Vectors are encoded by measuring their delta x and delta y, or the change in their x and y values from one end to the other. This is extra useful because when you position a vector at 0, 0, it can be used as a point in space. So we can use vectors to represent points in space or movement between points in space. Then, with vector math, we can do some pretty complex things with small amounts of code. The simplest vector math is probably the most commonly used, and that is addition. Addition is performed on vectors by drawing them end to end, or adding the x and y values of the vectors separately, as we do in our code. In a game, any object that moves will have position and velocity vectors, and each computer cycle the velocity will be added to the position, moving the object across the screen. Subtracting vectors is similar, but you draw the reverse of one at the end of the other, or subtract the x and y values separately in code. When you test for collision between your character and an object, if you subtract the overlap from your character's position, the object will be solid, but if you add the overlap to the object's position, your character will push it. Scaling vectors allows us to change the length of it. If you have 2 points, you can subtract one from the other to get a vector that points between them. You can then scale that vector and add it to the first point to find any point along the line or beyond. See, simple stuff. A couple of other quick ones. Clear resets the vector to 0, 0. Copy will copy the xy values of another vector onto this one. Clone creates a new vector with the same xy values as this one. And reverse just multiplies x and y by -1 to make the vector point in the opposite direction. Next, we find what the vector is known for, a number with a direction, using trigonometry. The number is called the magnitude, and we use Pythagoras' theorem to find it. Good old a squared plus b squared equals c squared, solved for c. The direction is found with the inverted tangent function a tan 2. It will return a value from -pi to pi in radians. Both pi and -pi point to the left, 0 points to the right, pi over 2 points down, and -pi over 2 points up. Distance is a helper function. Instead of creating a new vector and measuring the magnitude of it, distance just applies Pythagoras' theorem directly to 2 points. Perpendicular returns a new vector, but flips the values around and makes one negative to create a vector that points at a right angle from the original. Normalizing a vector will return a new vector that points in the same direction, but has a value of 1. This is done by dividing both x and y by the magnitude of the vector. Not to be confused with normalizing, a vector's normal is perpendicular to it and normalized. The dot product, named so because it uses a dot as operand, multiplies the values separately, then adds them together. If the value is positive, the two vectors are pointing in the same direction. If the value is negative, they are not. If you have a point and you want to know if it is on one side of a line or the other, you can find a vector from the start of the line to the point and find the line's normal. If they point in the same direction, the point is on that side of the line. As soon as the point crosses the line, the dot product will return a negative value, and the value that the dot product returns is the distance from the point to the line. Another useful trick is projecting one vector onto a second. This can be done by normalizing the second vector, then finding the dot product of the two, and multiplying the x and y values of the first by that number. This will give you a vector that is the same direction as the second, but is only as long as the first is along the length of the second vector. This can come in handy if you want to do something like bounce a velocity vector off of a surface. To do that, you find the normal of the surface vector, then project the velocity onto both the surface and the normal. You then reverse the vector projected onto the normal, and add it back to the other projected vector. This will give you the new direction your vector will be pointing. That's as far as I'll go today, but this is just the tip of the iceberg with vectors. We only need a simple understanding to use them in games, and the coming videos on game objects and collision will use them a lot. Thank you for watching Indie Dev Tools. If you like what you see, please like and subscribe and consider supporting us on Patreon.